question number 4. And questions like this can definitely be on the SAT test, so you have to be very careful when you look at things like that, on the algebra side of them, with equations and so and so. So let the function m of 4 equals 7x plus 25. If the square root of m of a over 4 is equal to 9, then what is the value of a? So this is what we basically have. And how do we go about it? All right? So let's go and see. Now also take into account that we have various responses here. We have 5 of them, and which one is going to be correct? So A is 10, B is 8, C is negative 20, D is 16, E is 32. Let's go for it. So what can we do? And what are we looking for? We're looking for A. We know m of x, which is 7x plus 25. And then we know that the square root is this one. So what can we do about it? So we can take m of a of 4 because we have m of x, right? So m of a of 4, what would that give us? So m of a of 4 is equal to then 7 times then a of 4, because that's what the x stands for now. So we replace a over 4 by x, okay, plus 25, okay? So that's what we have. And then we know that the square root of m of a of over 4 is equal to what? Is equal to 9. All right? So that means we can definitely take the square root of this one and then take it. So that's 7 of a over 4 plus 25. Square root of that is equal to what? Is equal to 9. So I'm interpreting this one here. Okay, so that is square root of a over 4, m of a over 4, which is equal to 9. Okay, so we can take that and then plug it in here. So that's the square root of that. Okay, so because that's the square root of this one here, so what's the next thing to do? So we got to get rid of the square root. We're solving for a, so that means we can square both sides. Because remember, whatever you do on one side, you can do it on the other side, because we square because we want to get rid of the radical, the square root. We want to eliminate the square root, so that's the reason why we take the square of both sides, okay? Because whatever you do on one side of the equal sign, you got to do the same thing on the other side. So once we do that, so the square root is gone with the square here, so you end up with 7 of a over 4, okay? And then plus 25. Okay, that is equal to what? A by 8 is 81. Are we good so far? So from here we can see that we can now, solve for a, right? So now we can just do what? Negative 25, both sides, so that we can cancel it from here, combine it with the 81. So we end up with 7 times a over 4. That is equal to what? 6, 3, 56. All right, so that gives us 56. And now we take it, move it to this side. So that's the same thing as having 7a over 4 equals to 56. All right, so solving for a, we have multiple ways of solving for a here. So we're trying to get a by itself by canceling 7 over 4. So you can either divide by 7 over 4 both sides, or you can cross multiply. So many things you can do, or you can multiply by the reciprocal of 7 over 4. So it doesn't matter which one you use. So we can cross multiply in this case. So this is 56 over 1. So when you cross multiply, you end up with 7a. 7a times 1 is 7a equals to 4 times 56. Okay? 4 times 56. Now, can we divide this by 7? Yep, we can divide this by 7 and 7. And a equals to what? So can we divide 56 by 7? Yes, because that's 8 times, right? So that gives you 4 times 8, because 56 divided by 7 is 8 times, right? And then what is 4 times 8? It's going to give us 32. And that's what we're looking for, a, which is 32. And that's the fifth answer here. All right? And we're good. So, ladies and gentlemen, you take your time and then you look at the problem and see which one, where you're going to start with, where you're going to begin, and then what is going to help you to get to where you want to go. So in this case, for example, we had to use the m of a over 4, okay? Plug it inside this equation here, the function here. So that's what we get first, and then we take the square root of it. So we square root it, and because square root, we know that is equal to 9. That's the problem that says it. Okay, then to get rid of the square root, to remove the square root, we take the square of both sides of the equals of the equation. And once we do that, the radical is gone, we solve for it, and then we solve for a afterwards, okay? All right.